In previous sections, we have built up tools for analyzing and graphing functions. And in the most recent sections, it was all focused on graphs. And I think it's good to kind of have a context for this where thinking about like graphing a function is really the graph is the culmination of all of your analysis of the features of the functions. And so in using computers, one of the beautiful things about computers is they can give you a graph immediately, but they present a challenge in that they don't necessarily always show you all of the important features in the graph. So you still have to use your understanding and use some calculus skills in order to poke around and find the features of those functions. So that's what's going to be happening in this section. The main tools that I use in exploring math, and this is true of math that I am exploring on my own, or when I am exploring for the sake of teaching, I typically use Desmos. This is my main tool, but anytime I need to do computations, I tend to go to Wolfram Alpha, and so you will see. You will see the book refer to CAS sometimes. So some of the problems actually say do this with a CAS. CAS stands for Computer Algebra System. And so that's basically just some sort of software that manipulates mathematical expressions. And so where Desmos will do some calculations for you and it will graph things for you, it doesn't compute things algebraically. Like it won't tell you what is the derivative of 2x plus 5. Okay, Wolfram Alpha does do that. And so Wolfram Alpha is a free service, and I pay for a pro account, but it like all of the things that I show you in these examples, you can do for the free account. And they also have a mobile app that you can get that I think costs like $3 or $4. They have a whole bunch of specific, like topic specific apps that I actually don't recommend that you get. I don't see any additional features in them. So just getting the regular app is gives you the full power of the whole system. But like I said, it is free to use on the internet. So, you don't necessarily need to get a mobile app. But so this is the sort of thing where, I'm looking at a function and I can ask, I can just kind of copy and paste. So here's the definition of this graph of the function that's graphed here. And I can ask, what are the zeros? And I can use the natural language input. There is math input, which has like all of the kind of functions and things that you might see in mathematical notation. I like the natural language input as a standard because it just I don't have to poke around and find symbols, and this way it's just you just ask for it. So you can ask like, what are the roots of, and I pasted that function, which I copied from over here. And so it'll give me roots. I can also, if I don't remember that they're called roots, then I can ask it to solve this equation. It looks like it's not actually giving me that. So I'll put in the word solve. So, you just use the words that you want to use. So it will calculate derivatives. So I can ask for the derivative of this. And, you might want to use the sort of shorthand notation. So that's d over dx of this and put it in parentheses. And so that will give you the derivative of this function. It will often give you far more information that you actually want to get, but you can kind of poke around and find the information that you need. So I can take this derivative if, I mean, this is a polynomial. It's not very hard to calculate the derivative, but with more complicated functions, maybe I don't want to spend the time calculating derivative by hand. I just want to have Wolfram Alpha calculate the derivative for me so that I can take that derivative and go back and use it in Desmos. I can also use it to calculate limits. So I can ask for the limit of this as x goes to 5. In this case, I just used this dash greater than as a shorthand for an arrow. It happened to work. I guessed that it might work, but if it hadn't worked, I would have just used the language that I used to... I would use the words. So this is kind of the beauty of the natural language version. Is you just put in the words that you would use to say this math stuff, and then it will translate it into the mathematical notation for you. So I can take the limit and I could say from the right. And so then that'll give me the one-sided limit. Anytime you ask for one-sided limit, Wolfram Alpha seems to give you the other one-sided limit as well. I can also ask for as it approaches infinity. So there's, so here's, lots of different things that I can do that use a very, very powerful engine here in Wolfram Alpha to do some mathematical calculations that I can go back and take that into Desmos as information to work with. Okay, so this is the overview of what we're going to be doing in this section, and I recommend that you look through at least a couple of the examples in detail. I know that the example 3 ended up being extremely complicated because I didn't give the idea of when you are using these tools to graph functions, one of the beautiful things about Desmos or any graphing calculator is it immediately gives you a picture with very little work. All you have to do is write in the function, and I can go and trace points on those functions. If I highlight the function, it will give me intercepts. And if I zoom in, it will also give me relative local extrema, local maxes and mins. So I can come down here and it looks like this is probably it's a local minimum. It looks like it's probably a global minimum. But this is, the problem is that the computer makes some decisions about what to display for me, and there's limitations in terms of how it is displayed. So you really need to go and do some math to figure out what all the features are and make sure that you're actually getting all of the features. And this is where example 3 ended up being pretty surprising how many features were hidden in here. What's going on in this gap was a little bit confusing. Is there just an asymptote at x equals 5, or is there 2 asymptotes or 3 asymptotes? Is there something else going on up there? And it turned out that there were some kind of very teensy-weensy little microscopic waves happening on this part of the graph. And we couldn't have seen that from just, the native graph that Desmos gives. We really needed to poke around and go back and forth. What was example 3? It was an annoying rational function that sure I could calculate the derivative of, but man, I just don't want to put the effort in. So I used Wolfram Alpha as a way of doing some of the algebraic computations, and then Desmos gives me the visualizations. Okay, so I hope you enjoy kind of going through here and using this as an opportunity to get more acquainted with the features of Desmos and Wolfram Alpha.